Hi again, everybody. It's Mr. Bullock, and this geometry lesson is talking about other angles in circles. We've dealt with inscribed angles, we've dealt with central angles, we've dealt with semicircles so far. So here's a central angle right here. If it comes out from the center of a circle, then it's going to be the same. If it comes out from the edge of a circle, it's called an inscribed angle, so it's always half this arc right here. Okay, and if it goes through the diameter right there, then it cuts the circle in half, so each side is 180 degrees. Okay, we know that already from a prior lesson. So here's some new theorems, you guys. A tangent and a chord that intersects at a point of tangency on a circle, then the angle formed is half the intercepted arc. So what this means is, here's my tangent. Notice I have it color coded. This is my tangent right there, okay, in purple. And then the chord is going to be in blue, so there's my chord, and the point of tangency is that little green guy right there, so it's all nice and color coded. I was feeling creative the other day. Um, then if they meet, then it's just like an inscribed angle, you guys. If it's on the edge of a circle, then it's half this intercepted arc. So half of 210 is 105, okay? All right, and then I could find this angle over here also. 360 minus 210 is 140, so this arc right here would be 140, so that means this angle right here would be, what, 75? So this is 150. Sorry, my arithmetic's wrong. So, or I can figure out this from this purple straight line right there is 180, so 105 minus take away from 180 gives me 75, and double that would give me 105. Okay, anyways, that's that theorem right there. Okay, angles formed inside a circle equals half the sum of the intercepted arcs and the vertical arc. So here's a picture on that, you guys. Here's an angle that's inside the circle that's not the central angle, so the center is somewhere over here. So there's some other things we got to do. So what we got to do is add this arc and add this arc and take half of that. That's what angle 1 is. Okay, and I highlighted them in blue right here. So if I add this arc and this arc and take half of that, that's what angle 1 is right there. It's half the sum of the intercepted arcs. Okay? So angles formed outside the circle is half the difference of the intercepted arc. So here this angle 1 again right here. So if I subtract this arc, this big old arc AB, and subtract CD from it, then take half of that, and that's what angle 1 is. Okay? Let's try some of this, you guys. So in each circle, find the values of x and y. All right, so we have this circle. It looks like we have a tangent segment out here, and we have this chord going right here. Okay, remember, if this is on the circle, so we just take half the intercepted arc, so half of 228, you guys. See that angle right there? Half of that is 114. Okay, and then what I'm going to do is use that 114 and that straight line right there. Remember, straight lines are 180, so if I take y and equals 180 minus 114, I get 66. Okay, so straight lines, that 180 trick you use all the time. Straight lines are 180. Okay, I'll do it again right here with this one in just a second. Okay, so here I have this inscribed angle right here is 118, so it is half of this guy, so I have to double it to get x. So when I double that, I get 236, so that's what x is right there. All right, so there's a couple of ways to get y right here. I did it the backwards way. You could have done 360 minus 236. That's probably the quicker way. But what I did the longer way, duh. Knowing me, I did a straight line as 180, so 118 plus 62, and then I doubled 62. But I could have also taken 360 because I know this is that big majority part of the circle, and the rest of it is this y over here. So 360 minus 236 is also 124. Okay, there's all kinds of ways to get these. All right, here's another one. Okay, I see x, so I'm going to get x first, you guys, because x has the intercepted arcs 63 and 89. So what I'm going to do is add those intercepted arcs right there and take half of that. So I get 76 degrees. And then so I'm going to go ahead and insert my 76. I guess I'm not. Okay, so then I'm going to use that straight line right there. And straight lines, again, are 180. So 180 minus 76 is 104. So that's what y is. All right, my kitty's attacking my foot here. Okay, so here's another one, you guys. All right. Okay, so I have x and y right here. Okay, looks like I have the majority of the circle. Here's 240, here's 76. And then so this is the rest of the circle right there. X is the rest of the circle. So if I take 360 and subtract off the 76 and 240, I get 316 when I add those together. And then so x must be 44. So I'm going to go ahead and put 44 in there for x. And then this is outside the circle, so I'm going to subtract those intercepted arcs right there. I'm going to subtract 76 and 44, or 76 and 44, sorry. Um, let's see, I did something wrong right there. I changed my number right there. So 76 minus 44, so that's a wrong number. Let's fix that real quick, okay? This is going to be 76 minus 44 is going to get me 32. 32, whoops, sorry. I make mistakes all the time in class. You guys, my kids catch me all the time. So 16, is that right? Did I get that right? 76, 32, I think so. All right. If not, you guys will tell me. Okay, here's another one, you guys. Okay, I got a circle. I got these arcs right here. Okay, what I'm going to first do, I think, is get x with my straight line right there. My straight lines are 180, so 180 minus 102 will tell me x is 78. Okay, so I'm going to go ahead and put that 78 in there. Remember, I go fast in these videos. You can pause and rewind and all that stuff. I'm just trying to save time. And then that 78 is half the sum of its intercepted arc, this y plus 95. Okay, I don't know if that's the center or not. Nobody told me it's the center, so I got to use this principle right here and subtract them or add them together. All right, so multiply both sides by 2 to get rid of that half. 78 times 2 is 156, and I got rid of that half, and then subtract 95 from both sides, you get 61. Okay, I think I have one or two more of these problems here. All right, so here I got another circle, and what I'm going to first do is use that 44 and the 30 and the x. That 44 is, or that 30 on the outside is half the difference of x minus 44. So I'm going to multiply both sides by 2, and I get 60 equals x minus 44, and then add 44 to both sides, and you get x equals 104. So I'm going to go ahead and put 104 right there, and then I got a whole circle right there, 360. So y is the rest of that stuff, so you should get 107, as long as I did my arithmetic right.